So in front of us here we have a variety of examples where we are going to factor either a trinomial or a binomial into its respective parts. So in the first example here we have a trinomial x squared minus 11x plus 18. So this is an example where we're going to do a little reverse FOIL. So I'm going to preset my two sets of parentheses for this problem here. And so remember, I'm looking for two things that are going to multiply to make this x squared, which hopefully from experience we know it's going to be x as the first thing in each of the sets of parentheses, because if I FOIL, x times x will get me back to x squared. And then I have to figure out what are going to be the trailing numbers. And so we need to find two numbers that multiply to make 18, and at the same time they have to add to make 11. So there's any of a variety of techniques that you may have seen before for this. I just try to start to go through the various factor pairs of 18 and then see which ones combine to make 11. The other thing to do here, though, before we even get to the numbers, is to determine, if we can, do we need two positives, two negatives, or one of each as these numbers that are going to be in the back half of each set of parentheses. And so for that, I look at that number and I'm multiplying to make a positive. Well, the only way I can multiply to make a positive is if both numbers are either positive or both numbers are negative. But at the same time here, I need to have those numbers add to be a negative. So the only way this can factor is if both of these numbers are negative. So that kind of helps me take care of that part of it. And so now I go through the factor pairs of 18. We can go 1 times 18. We can go 2 times 9, we can go 3 times 6. And the only one of those where the numbers add up to make 11 is 2 and 9. And so then it does not matter which order we put those numbers in. We could have gone x minus 9 and x minus 2, but they do both need to be negative, and that's the best that we can do. The next one is a sum of cubes. So in this case we've got x cubed is the lead piece, plus 27. 27 is a perfect cube as well. So we can think of this as x cubed plus 27, or it might be easier to say x cubed plus 3 cubed. And so I'm going to write out the pattern that we had from the previous slide, where it was u plus v times u squared minus uv plus v squared. And so in this case, our u, that first piece in our factorization, is the x, and then the second piece, the v, is going to be the 3. So everywhere where I see a u, I'm going to replace it with x. Everywhere where I see a v, I'm going to replace it with 3. So u plus v becomes x plus 3. Oops, let's try that again. And then u squared, u is x, so u squared is x squared, minus u times v, so u times v gives us x times 3, or 3x. And then finally plus v squared, well if v is 3, then that's plus 3 squared, or plus 9. And it may seem like we should be able to factor that second set of parentheses, but we cannot. That there is the best that we're going to be able to do. The only way you're going to factor that is if you memorize this pattern here. Likewise, you have to memorize the difference of cubes. We might see that come up later. Last example in this top row, we've got 8 minus 2x squared. So I mentioned it earlier, I've kind of glossed over it so far because it didn't apply, but you should always seek to try to undistribute whenever you can as kind of a first step. So in this case, I can see that there's an 8 and a 2 that's in common, so I can factor out a 2. I can undistribute a 2. So if I factor out a 2, I'm going to be left with 4 minus x squared. Now, I'm kind of obsessive over having the binomial or whatever I'm left with in standard form inside the parentheses. So what I'm going to do is, instead of just factoring out a 2, I'm going to factor out a negative 2 instead. And what that will do is that will flip around the subtraction that's inside the parentheses. So if I take out a negative 2, and I could have just gone straight here, take out a negative 2 from the very beginning, that leaves me with x squared minus 4. And so now that's just set up in a little bit more familiar format with the variable p squared coming first, minus 4. And now hopefully we recognize that x squared minus 4 as being a difference of squares. So that's where the u squared minus v squared factors into u plus v times u minus v. So that one should be a little bit more familiar from our Algebra 1 days. And so we're going to factor this into two sets of parentheses. It's going to be x as the first piece in each of the sets of parentheses. And then the square root of 4 is 2. So it's going to be a positive 2 in one of the sets of parentheses, negative 2 in the other. And again, it does not matter which order you put the 2 and the negative 2. But we don't want to forget about that negative 2 that we undistributed at the very beginning. That's a part of our solution. The next one, unfortunately, is the worst of the bunch, but at least we get it out of the way. And the reason I say this one is the worst one is, first of all, I look at that and there's nothing that I can undistribute. And so that means I'm stuck having a 2 in front of my x squared term there. So when I break it up into the two sets of parentheses, the lead piece, unlike the one above it, is not just going to be x and x. I'm going to have a 2x and an x. And what that means for us is when I look for the factor pairs of 21, 1 times 21, or 3 times 7, I'm not just looking for two numbers that multiply to make 21 and add to make that negative 1 that's in the middle. Clearly, neither of those factor pairs is going to combine to make negative 1 in any way, shape, or form. And the reason it doesn't work that simply is because of the 2 that's in front of the x. Whatever I put into this spot right here, it's not going to be multiplying x, it's going to be multiplying 2x. And so that's going to play a role in our factorization. Now, we also have to determine whether we're looking at two positives, two negatives, or one of each. And so I look at the negative 21 that I'm multiplying to make. I need to have one of each. I have to multiply a positive times a negative. But again, where I put the positive and where I put the negative matters, because on the one hand, if I go plus and minus like this, I'm going to have a negative number multiplying the 2x and a positive number multiplying the x. Or if I reverse it, now I've got a positive number multiplying the 2x and a negative number multiplying the x. So really we're just kind of in guess and check territory here. Again, there's some other techniques where you can draw like a box and try to figure it out. I just kind of go with the brute force guess and check approach. And so in this case, I'm going to guess that it's going to be negative over here and positive here because I need the middle to turn out to be negative. And so it's more likely that I'm going to have a negative multiplying the larger x, the 2x, than having the negative multiplying the smaller x. I might end up wrong, but that's going to be my initial guess. And I'm also going to rule out 1 times 21. It's just impossible to see how I'm going to get to negative 1 in the middle there if 1 and 21 are the two factors of 21 that I'm going to use. So it's got to be the 3 and the 7. And hopefully as I'm talking here, you can see if it's going to work, it's got to be a 3 multiplying the 2x, because that gives me negative 6x, and then the 7 multiplying the x gives me 7x. Now if you'll notice, I have this incorrect for what the solution to this question should be. If I kind of clear this out here, we're supposed to end up with negative x as that middle term, but we're ending up with positive x. So what that means for us is I've got to just reverse the positive and negative signs here. So this should be positive over here and negative. My guess was wrong, but that's how it goes. And so now I'll end up with a positive 6x for one of the middle terms. I'll end up with a negative 7x, giving me the negative x in the middle that I need to have. And I already know the other parts of the problem work. 2x times x was chosen so that it would multiply to make 2x squared. And the negative 7 and the positive 3 I know are going to multiply to make 21. So this is my correct factorization. For the next one, it's subtle, but this is another difference of squares. 81 is certainly a perfect square. So too is a to the 4th. Square root of that would be a squared. And likewise over here, 16 is a perfect square. b to the 4th is a perfect square, just like a to the 4th is. So what we have here is a difference of squares. So we're really along the lines of what we saw in this example here after we turned it around and made it x squared minus 4. So I'm going to break it up into two sets of parentheses, and so now I need the square root of 81a to the 4th. And so that's going to be 9a squared. That's going to be the first piece in each of the sets of parentheses. And then the difference of squares pattern is I go one positive, one negative, so plus and minus in either order. And now I need the square root of 16b to the 4th, so that's going to be 4b squared in both of those. Just one positive, one negative. Now you may think that we're done. Certainly this piece here, we're not going to be able to factor any farther, but the second set of parentheses is another difference of squares, 9a squared minus 4b squared. So I'm going to leave this first set of parentheses, 9a squared plus 4b squared, because there's no way to factor a sum of two perfect squares. But here I have a second set of perfect squares being subtracted, so I'm going to apply that exact same pattern to break it up into two sets of parentheses. The square root of this 9a squared is 3a, so that's going to be the first piece in each of the sets of parentheses. It's going to be 1 plus 1 minus, that's our difference of squares pattern. And then we've got the square root of this 4b squared, so it's going to be plus 2b and minus 2b. And that is as far as we can go. The last one in this bunch, so 64x squared minus 16x plus 1. Again, unfortunately, there's nothing that we can undistribute from both or all three parts of the expression, so we're going to have to break it up into two sets of parentheses right away. And at first I look at that 64x squared, and there are so many possible ways that we can break that up that I just don't even want to think about it. So I'm actually going to pause there and not worry about the first piece of what goes into the parentheses. Instead, I'm going to take advantage of the fact that I have a 1 here as the last piece of the expression. And the only way that we can multiply to make 1 is 1 times 1. And I can also leverage the fact that I've got to multiply to make a positive, so both of these ones have to either be positive or negative. And so I'm going to look in the middle here and see that I have to have a negative in the middle term, so that means both of these are going to have to be negative. And so now I just have to figure out, it's almost like we're doing this problem in reverse. Now I have to figure out a factor pair of 64x squared, of 64, that multiplies to make 64, but adds to make 16. And the reason we just need to add to 16 is because both of these numbers, whatever we put in this first piece in each of the sets of parentheses, needs to just multiply a 1. So it's just going to be that number. So 64, hopefully we jumps out at us that it's 8 times 8 that is going to multiply to make 64, but add to make 16. So this one is called a trinomial square. It's one of those things that every textbook points out. So you'll see examples of this in our textbook in the pages preceding the homework. But really, I don't see that there's much hope for trying to factor this into some sort of pattern unless you really are paying attention and you recognize it as such. But otherwise, you kind of got to have to take this approach that we just did here and just factor it the same way we did the first one of the bottom row.